Let us build a program in C, and this program is to multiply two matrices. This particular program appears both in BSc. We have BSc practicals. In this, we have to multiply two matrices, as well as in BCA, wherein we are supposed to multiply two matrices, and it is in the part B. Now, when it comes to the BCA, you are supposed to even perform the addition with the menu driven. But I'm going to just explain how to multiply the matrices so that it is same for both BCA and BSC. Now let's look at what we are supposed to do. And we are given the matrices, like we have the matrix here with the rows and column, and we have one more matrix with the rows and column, and we are supposed to multiply the matrix, one matrix with the other. How do we perform the multiplication? That's very important. Now suppose if we are given the matrices, we take the first element from the first matrix and we multiply it with the first element of the next matrix. Then we take the second element in the first row. However, we go to the second row here and then we multiply with this element. Similarly, we take the next element from the first matrix and we multiply with the first element in the third row of the given matrix. So in other words, we are going to multiply the elements horizontally as well as vertically. So this is what we are going to do. Suppose if you want to multiply this, how is it going to look like? So this is how it's going to look like. The first element of the matrix A is multiplied with the first element in the matrix B, that is the first of here. Then the second element along the same row is multiplied with the first element of the second row of the matrix, and the third element is multiplied here. Now when you multiply it, when you multiply this with the other, so when you multiply one element with the other and you multiply the second element with the second element, and we take the third element and multiply it with the third element. Once we multiply it, we add them together. So if you look at the option over here, so we multiply this with this and then we add, okay, this multiplication, whatever the result that we are getting. So when I multiply this with the other, whatever the result I am getting, I add it and then take the second with the second, I add it, and finally I take the third with the third and then add it. So this, whatever I'm getting, this whole thing, after multiplying and adding, I'm going to put it over here. Okay. What about the remaining element? So the remaining element is also same for the next element. So this element, what are we going to do? We do the same thing. We take the first row, corresponding element of the first row will be multiplied with the second column element, the corresponding second element column, or the second column element of the next matrix. So this with this with the other one, and finally the element are multiplied. In the same way, how do we get this element? This element is same. You take the first row element and multiply with the corresponding element of the last row. What about this element, the element which is here? The idea remains same. We start with the second row and then we multiply it with the first column. What about this element? We take the second row and we multiply with this one. What about this element? we take the second row and multiply it with the other one. So if you go to the next, this is how it's going to look like. So we take the second row, multiply it with the second column, and finally, what about this element? We take the element along this and we multiply it over here. Remember, when you multiply one element with the other, so when you multiply this element with this element and this element, corresponding element, you multiply it, and the corresponding element you multiply it. Remember, the product of this multiplication has to be added. If you notice over here, I am adding all the products. When I multiply this with this with this with this, when I get the product, I add this product. What about the last row? The same story. When you go to the last row, you take this element, the element along the last row, multiply it with the elements along the first column. Same thing. What about this one? You're going to do the same thing. You take the element along this, you multiply it over here. Okay, and this process will continue till the end. So this is the last one that you are going to do it. Now there are a few things you must understand. What if, just for your understanding, what if I have one more? So let me go over here, and what if I have one more? Let me take one more row over here. What if I have this kind of matrix? If you notice over here, this matrix is 3 cross 4, 3 cross, this is actually 4 cross 3, this matrix. If you notice, there are 4 rows are there, and this is 3 cross 3 matrix is there. So will you be able to multiply it? The answer is no. Why? You know very well, you multiply, you take this and you multiply it over here, and then here, then here. Okay, and you know that. For the second, you take this and you multiply it. Okay. Okay. For the third one, you're going to do this and you're going to multiply it with. Okay. What about the fourth row? What will happen to the fourth row? Fourth row, you take the same thing. You take the elements and you multiply it with this element. Okay, so what is the, how many rows are there in this? 1 2 3 4. Okay, so 4 rows are there. How many columns are there? 1 2 3. So 3 columns are there. And how many rows are there in this one? So I'm going to write 3 columns. How many rows are there in the next matrix? There are 3 rows are there. So this is 1 2 3. And how many columns are there? Okay, so this is what you get. You notice that there is a common thing between them. So you notice that the number of columns of the first matrix is same as the number of columns of the second matrix. You'll be able to multiply it. Now let's, for your understanding, so let me do this one. Now suppose if I have one more matrix, okay, one more column of the matrix, one more columns here. In this case, what's going to happen? Now, if you notice, when I took this one and the corresponding element along this one, now what happens? Okay, all the elements along this with the corresponding elements on the other. So when I multiply it, you notice that first element is multiplied with the first element, second element is multiplied with the second element, third element is multiplied with the third element. What about the fourth element? Fourth element, there are nothing is left over here. So what is the dimension of this matrix? There are 3 rows are there in this matrix. There are 3 rows are there. Okay, and 4 columns are there. Okay, so this dimension is 3 cross 4. What about this matrix? There are 3 rows are there, no doubt. There are 3 rows are there, and there are 3 columns are there. So there are 3 columns are there. But what you notice over here is that these two, the column number of the first matrix, that is this column number of the first matrix, is not matching with the row number of the second matrix. So in this case, it is not possible to multiply the matrix. So how can we multiply the matrix? We can multiply the matrix. Suppose if you take, in general, if you take, if the matrix has m number of rows, I have taken the 3 rows over here. If there are m number of rows and n number of columns, and let's say 1, 2, 3, 4, n number of columns. Okay. If you want to multiply it with some other matrix, let me say there are p number of rows are there, some p number of rows are there, and there are q numbers of columns are there. Here it is only 3. And what is the condition? The condition is, if you want to multiply them, n must be equal to p. That means to say that number of columns along the first matrix must match with the number of rows of the second matrix. So number of columns must match. In this case, this is one extra which is not matching with the number of, there are 4 columns are there, there are 3 rows are there. It is not possible to multiply. That one thing you must understand. Now let's look at the matrix as such. Now this element in terms of the matrix, this one that you notice over here, what is its position? The, you know very well, in array index starts with the 0. So this is the 0th index, the row number, and 0th column number. So this position is 0, 0. That is its position. What about the, we'll just remove this one. What about this location? This location is, if you look at here, this is 0th row, okay, 0th row, and first column. So this is the first column. Similarly, if you look at the second row over here, in the second row, the row number is 1, the column number will be 0. So this is 1, 0. Again 0 and this is 1 and 1. So this is 1, 1. This is 1 and 2. I'm just writing not the value here. The value may be 6, value may be 10, value could be anything. But what I am interested in is the location. So this location is, if you want to know what is this location, you go here. So 6, this is in the row number 1. Remember, index always starts from 0. Even though we start counting from 1, 2, 3, 4, index always starts from 0. So this is the 1 row. And what about the column number? This is the column number 2. So this is 1, 2. Okay. What about this element? Let me put it over here. What about this element? So this is the row number 2 and the column number 1. So this is 2, 1. So you multiply the element which are there. Suppose if you call this matrix as A, so this location, you want to write this location. How do you write this location? This is going to be A of 1 dash A of 2. Okay, so this is the A of 1, that is the row number 1 and the column number 2. So this is how you represent. Okay. Now let's come back to the multiplication story again. Okay. Let me go over here and let me put the multiplication. So how do you get the multiplication? So here you notice that this, I'm talking about this one. The first element is 1, 0. Second element is 1, 1. Third element is 1, 2. This is, I'm just talking about the location, not the element. The element value may be different. Okay. So what is common among all of them is this 1. 1, 1, 1. Along this 1 is common. Then the value is changing 1, 0, 1, 1, 1, 2. But you notice that the first, that is the row number, is same. What about the this side, what is common here? You notice that 0 is common. What is this 0? 0, excuse me, 0 is the column number. So this is the column number. This is the row number. So you notice the two things over there. So one is this this particular thing, one, and the other one is the column number. So you notice that along this, you notice that at one time one is remaining constant. What about the other row? If you look at this row over here, what is common again is here the row number is common. Okay, what about this row? Again, row number is common. What about in along this? Along here, you notice column number is common. Along here, column number is common. Column number is common. But there is one other thing you will understand. That is, if you look at here, look at this 0. This 0 is multiplied with this. Remember, this is common. This is common. So I'm not going to touch this. This 1 is common here. So forget that one. But what is important apart from this is, you notice this is 0. 0 is multiplied with the 0. This is 1. 1 is multiplied with the 1. 2, 2 is multiplied with the 2. So what you notice over here is these values are not same. This may be 1, this may be 0. But this column number, this column number, this this column number, okay, is matching with the row number of the second matrix, row number of the third matrix. In other words, the column number of the first matrix is matching with the row number of the second matrix. So in a very simple way, you take for that anyone for that matter. So the column number of the first matrix matches with the row of the second matrix. Okay, now I want to introduce a variable here. So I will represent every row of this matrix, as I. So just a variable I. So if the I value is equal to 0, that means I am in the first row. Here all are 0. Okay. So if I is equal to 1, if you say I is equal to 1, then I am in the second row. Here, if you notice that all I are 1. What about if I is equal to 2? If I is equal to 2, you are in the next row, that is I equal to 2. And I am going to take the next one, and that is the j. Okay. So I'm going to take the value j here. So what about this j? Okay, this j, if you look at here, so if you just take this one along with the other one here, so j value is, if I take this one as j, so j is okay, anything. So j is 0 means this, j is 1 means this, j is 2 means this. Now there is one other thing that we have to match. What is the one other thing? We have to match the column number, column number, column number, and we have to match the row number, the corresponding row number and row number. So this is same. You notice that this is same. So this is same. I'm going to call that as k. So I'm going to take three variable. I value, I'm going to take it for the row of the first matrix. Okay. J, I'm going to take the column of the second matrix. Okay. And k is common. So k is common for the column of the first and the row of the second. So remember that particular thing. So this is common. So let's start with the program. I'm going to use the code block for writing my code because showing it in the turbo C is a bit difficult task. So let's start with the three matrices. So I'm going to take the three matrices. I'll call the first matrix as A. Let me take them as integer. I'm going to take the first matrix as A. I'll take 5 comma 5. So maximum element is 5 comma 5. Among them I may not be using all the 5, but I will use only 3 here. So next I'm going to use the next matrix as B, and the last matrix I call it as C with the 5 comma 5. Can you take 3 comma 3? Answer is yes, you can take, because during the examination I don't think so you will be able to type 5 cross 5 matrix. What is 5 cross 5? Is 25 element, 5 into 5, 25 element you have to type it. So it is going to be a difficult task. I'm going to take a 3 variable I comma j comma k. I'm going to take 3 of them. Okay, and I need, okay, the dimension. So I told you the first matrix is m cross n. So I take m and n. The second matrix I'm going to take p cross q. That's the second matrix. Okay. So let's start with the first matrix over here. So let me take the variable ijk for the three counters that we are going to use. One is the row and the column and the common one. Okay. So let's first take read the values of m and n. Okay. M and n, for your kind information, I am taking the dimension of the matrix. This is m cross n matrix. So there will be m number of rows, any number can be there, and n number of columns will be there. So this is what I want to show that. So I'm going to read this m cross n matrix. How do I going to do that thing? I'm going to use a printf statement, and I'm going to say printf, and I'm going to say enter the dimension of first matrix. Okay. I'm going to say that enter the dimension of the first matrix, and I'm going to read that dimension, and I'm going to say scanf. Okay, percentage d, because I'm using the integer percentage d. If you notice that both of them are integer, so these two, what you notice over here, these two are integers. So whatever I have taken are all integers, and I'm going to read the value of m and n. So this is the dimension m cross n. I'm going to read it. Now because I am using the code block, I can use a simple Windows copy paste option, which is much easier. And I'm going to say I will read the second matrix. So for the second matrix, I'm going to take p comma q. Okay, so let me make it as pq. So what is that I am taking is for the first matrix. So I take how many rows are there. I assume that m number of rows are there. How many columns will be there? N number of columns will be there. So that's why I take m into n. For the second matrix, how many rows will be there? M number of rows will be there. P number of rows will be there. And how many columns will be there? Q number of columns will be there. So that is what I'm taking in general. Okay, so here it may be 3 cross 3, 4 cross 4, or anything. In general, it is m cross n I am taking. But very important thing, what is very important thing here is I know I've already told you the column number of the first matrix and the row number of the second matrix must match. So in other words, suppose if you have the matrix m into n, okay, if you have the matrix m cross n, and in the next matrix if you have p cross q, then this n and p must be same. If they are different, you will not be able to multiply it. So I am going to check for that one. So I'm going to say if, a very simple one, if n is not equal to p. Remember, these two must be same. these two must be same. If their values are different, it is not possible. We say that matrix are incompatible. Okay, so if they are not the same, I am going to put a printf statement, and I'm going to say that matrices are incompatible, incompatible matrices. Okay, matrices. Okay, that's it. So I'm going to say that these matrices are not matching. Else, see, the one thing is some students, what they do is they put if like this. They start if like this, and else like this. Okay, this is remember what C says is you put the open and close bracket. Yeah, my style of doing it is I like to use it. There are many people who follow my idea also. I like to use it in this way. Immediately I begin with the floor bracket and then close it. So don't get confused. It is your style. Okay, you want to put it in any way you want it, you can put that thing. Okay, so if it is true, we have to read the element into the matrix. So if m is not equal to n, then we say that the matrices are incompatible. So let me quickly run this program, and I'm going to show you what is going to happen. So I'm going to run this particular matrix. Okay, and let me first save it, and then let me try it one more time. Okay. If there is any error, I'm going to see that error. So I will take, say, remember, I'm reading m cross n now. So when I say m cross n, if I say 3 space 2, so this means to say that I am taking 3 rows and 2 columns. In the second one, remember, if I take 3 comma 2, will it going to multiply the matrix? The answer is no, because I told you that m and p, these two values must be same. But you notice, what you notice over here is this is 3, this is 2, these two are not matching. So when these two are matching, you cannot multiply the matrix. So I must get the answer as if I just put enter here my program, I will just stop my program by writing one simple get ch. I'm going to say get C. Okay, get ch should be there. Okay, get ch. If it is, remember when I say get ch, if it is not detecting, I have missed it. One more include statement, which is the include which you are already writing in your turbo C, that is console input output dot h. Conio.h. I'm missing it. So let me run it one more time, and let me try it here. So if you look at this one, I'm going to take 3 comma 2 and again 3 comma 2, sorry, 3 comma 2. Now you notice that these two are not matching, and I must get a message saying that no, these are not compatible. So sorry, I get this hello world. I don't know from where that hello world came. Okay, that is the default message. I mean, just remove this, that hello world is coming as part of the project of code blocks. Let me run it one more time. Sorry about that. So this is 3 comma 2 and 3 comma 2. They are not matching. Why they are not matching? Because these two must match. If they are not matching, then you cannot multiply the matrix. Okay, suppose if they are matching, let me run it one more time. If they are matching, what's going to happen? If you say 3 comma 3 and next also 3 comma 3, okay, are they matching? Yes. Remember, I am not interested in this value 3 nor this value. They can be anything. But what is interesting or what is required is this and this. These two must match. If they are matching, then you must or it is possible for you to multiply the matrix. Now when I press here, nothing is going to happen because I have not inputted the elements into the matrix. Now I know that the matrix are compatible, but I have to put the values into this matrix. Okay, how do you put the values into matrix? So this is I have to put the element row wise. First I'll put this row, I'll fill this row, then I'll fill this row, then I'll fill this row. So I'll take, I have already told you, I take the value I for the row. What about the column? In the first row, if you look at this one, in the first row, you take this first row, first column. So if you take this is ith row and this is jth column. So I need two variable. So when I is 0, j is 0, this is. When I is 0, j is 1, this one. When I is 0, j is 2, this one. So I need two variables and I continuously have to input it. How many times I have to input it? Remember, this is a m cross n matrix. So I value can start from 0 up to n minus 1. So for example, if you have 3 cross 3 matrix, so you know very well this is a 3 cross 3 matrix because there are 3 rows are there, 3 columns are there. So this is a 3 cross 3 matrix. So what are the values I can take? Even though this is a 3 cross 3 matrix, what are the values I can take is I can take the values from 0, 1, 2, 1 less than this one. What about the j value? 0, 1, 2, 1 less than this value. Okay, so less than that value. So I can start from 0 up to 2, 1 less than the dimension. How do I put that thing? So I'm going to say here, I'm going to just close this one. I'm going to just put it here. And I'm going to say printf because I have to show some message to the user. And I'm going to say enter. Okay, just make it beautiful. Enter m cross n, okay, elements into first matrix. I'm going to say that. Okay, what is this m? This is m, this is n. So m cross n matrix into this element. So this part will be m value, this will be n value. So if I take the value of m as 5, so this is going to come as 5 cross 5. Okay, so let me just run it. So remember, I'm reading m and n first. So this is a scanf statement. I'm going to read m and n. I'm not going to use p and q now. So just run it. And I'm going to put the value as 3 comma 3 space 3. Second matrix 3 space 3. Are they matching? Are they compatible? Yes, because these two are both are 3. They are compatible. So I press enter. So what is that I'm going to get? Enter the elements into 3 cross 3 matrix. What is this? A 3. This is the value of m. What about this one? This is the value of n. Suppose if I run it one more time, I'm going to just close it and I'm going to just run it. And I'm going to take one random number. I'm not going to input this matrix. So I'm going to say 4 cross 3 matrix, okay, and 3 cross 5 matrix. Can you multiply this matrix? The answer is yes. Why? Because only one condition is these two must match. Others need not have to match. These two need not have to match. Okay, remember that thing. Okay, so again, if I put enter, what is the answer you are going to get? Enter the element or the enter. This is 4. This is m, that is the value of m, and this is the value of n. So m cross n matrix. So in next one, let me run this one and one more time. Can you multiply this matrix? So I'm going to just say 1 cross 4 into 4 cross 3. Can you multiply? Answer is yes, you can multiply. Why? Because only one condition. What is the condition? Condition is these two must match. Are they matching? 4 and 4 are matching? Yes. Then it is possible. Technically it is possible, but we will not, I will not demonstrate that thing. It is possible. So let me go to the first matrix now. Okay, so let me go over here. So I have this first matrix over here. So m cross n, I need two looping condition because I need the values of I must change from, say, look at this, I value has to change from 0, 1, 2, 3. So 0, 1, this is 0, 1, 2. J will also have to change from 0, 1, 2. So I need both of them. So I'm going to say for I is equal to 0, I less than m, less than, not greater than m, less than, I am pressing less than m, okay, I plus plus. So that is my first for loop. Okay. So this is I value starting from 0, 1 less than m. That's what I told you. Similarly, I'm not going to type it again. I'm going to just paste it here. J value starting from 0, j less than m, and j plus plus. Okay, so this is it. So I value is starting from 0, 1, 2, 3, and so on. J value 0, 1, 2, 3, 4 up to n. Okay, what is that you are going to do? You are going to read the element into the matrix. So how do you read the element? Remember, all of them are integer, and for integer you say percentage d, and I want to read the element into the first matrix. That is, the name of the matrix is A, and I'm going to say A of I comma j. Okay, so I am reading the element into the matrix. So this is simple as that. Okay, so let me just put a breakpoint over here and let me run it. Let me show you. Okay, there is some minor bug there. And what is this? Okay, the bug may be because I think expected declaration at the end of the input. Okay, where is the input? Okay, where is the declaration? For j is equal, for I is equal to 1 to m, and I think j is equal to n. This is it. This is it. And am I losing one else statement? I think I have not put one loop here. Let me run it one more time. Okay. Okay. Done. So I'm going to just put the matrix. I'm going to just say 2 cross 2. Okay, 2 cross 2, very simple 2 cross 2 matrix. Okay, very half of it. So when I press enter, so it is going to ask me, okay, enter the element into the matrix. So if I put the element into the matrix, whatever I am putting this element here, okay, if I put the element, this element must go to the A matrix. Okay, I'm going to just put slash n here just for brevity. I can just put slash n here. Just close this one, and I'm going to just put slash n here so that it will come in the next line. Otherwise, it's going to be a bit problematic. So let me run it again. Okay, so when I run it again, machine, okay, I will not run it. Okay, when I run it again, let me say 2 cross 2 matrix is my matrix, 2 comma 2 is my matrix, and the second matrix is 2 comma 2. Okay, now you notice that the first thing you must understand is how many places we are reserving. We are reserving 5 cross 5, very large matrix is there. So this is 3 cross 3 matrix. It is going to be 5 cross 5. This very lengthy array is there, out of which we are not using these elements. We are only using 2 cross 3. In this case, only 2 cross 2 is being used, even though we have the provision for 5 cross 5. Even though so many reservation has been done in the memory, so you are reserving lot of memory in the memory, in a lot of place in the memory, but you are only using small out of it. So many are there, but out of which a very small number is being used. So 5 cross 5 is my reservation. So if you look at the memory over here, you notice that this is the matrix A, and you notice that the matrix A, okay, 5 cross 5 is there. So 5 means 0, 1, 2, 3, 4. So, and you notice that all of them have, so what you notice here is we have garbage values which are there in the matrix A, that you must always understand. Whenever you are using a variable, initial value of the variable will be garbage. So you can notice all of them have a garbage value inside it. So whether it is row 0, row 1, row 2, or any other row for that matter, there is garbage value. Now I'm going to just proceed with the program. I will just stop this program, and I'm going to put the breakpoint slightly here at this get ch, so that I can show you what's going to happen when I enter the value. So I'm going to just run it one more time, and I'm going to take 2 cross 2 matrix, and again 2 cross 2 matrix, and I am supposed to enter the value, let's say 10 into the matrix. So I'm going to just enter the value. So I have a breakpoint here. So I'm going to just run the breakpoint, and I'm going to enter the value 10, 20, and let me put 30 and 40. Now, before I press enter, let me show you that the array A here has all the garbage value. So all the rows has a garbage value over here. As I press enter, you notice that the values for A0, A00 is 10, A01 is 20, and so on and so forth. You notice that the values for A02 is not been added. Okay, so if I run one more time, let me run it one more time, and I'm going to just show you what is going to happen. So even though you have a very large array that is reserved in the memory, we are going to make use of only small part of it. So the remaining part, whatever is there, there is garbage over here. So we will not consider them in the program. Okay. Let me now run this, remove this, and let me create one more array. I've inserted the element into the first matrix. I'm going to use the control C and control V, and I'm going to enter the element into the second matrix, and I'm going to just say enter the element into second matrix, and I'm going to just say this is P comma Q. This is P comma Q will be my second matrix. Again, I'm going to make this as P comma Q. I'm just reading the element into the matrix, and this matrix is going to be the matrix B here. So I will read the values into two matrices. Okay, let me just run it, and I'm going to just put a breakpoint over here, and I'm going to run this program one more time. So the first one that I'm going to do is I'm going to go for a 3 cross 3 matrix, and again 3 cross 3 matrix, and now I'm going to enter the value 1, 2, 3, and 4, 5, 6, 7, 8, 9. So this is the value that I am typing over here. So this is 1, 2, 3, 4, 5, and so on and so forth. So A00 will have the value 1, and A01 will have the value 2, and so on and so forth. So when I press enter, now if I go back to the array over here, now this is not going to be updated so easily unless I get a breakpoint here. Now if you try to open here, it is going to show me the old value because I've not set the breakpoint. Now I'm going to enter the value as 1, 0, 0, and 0, 1, 0, and 0, 0, 1 into the two matrix. Now my program will not terminate because I have a breakpoint here. Now if I go and look into the matrix over here, you notice that 1, 1, 2, 3, that is this element that I'm talking about. This element has been added, and next I have in the row 1, that is the, if you look at this one, row 1 here, this is the row. Okay, row 1, 0, 1, 1. Okay, so this is 1. I will just highlight here. This is 1, 0, 1, 1, and 1, 2. You notice that these many values are there. 4, 5, 6 will be there. If you look at the matrix over here, so 1, 0, 4 is there, 1, 1, 5 is there, and 1, 2, 6 is there. So these values are as is added, even though that shows the code block will show it in a different manner, but you are going to see that thing. Again, you have 7, 8, 9. That is the last set of values. Similarly, for the other matrix that I've inserted 1, 0, 1, this is the matrix A. If you look at the matrix B here, you have 100, and that is the value that I have typed here, 100. Then I have typed 010 in the second row. If you look at the second row here, 100, and I have 001. So here you notice 001, and that is the values that I have inserted. Now I need to compute the values. So let's go ahead and let's do this part. I'm going to just stop my program from continuing. Now it's the time that we are supposed to multiply the matrix. As I've already told you, I have to multiply the values like this. So the first row and the first column. So how do I do that thing? Again, I've already told you this is, if I take this as I, okay, the next one I can take as a j. You can take it any variable you want to use it, so it's up to you. Whichever value that you want to use it, you can always use that thing. So I will take this variable as I, and the other variable as j. Okay, I'm going to take two variable. So let's go ahead with the two things, and before I proceed, let me tell you. So here you notice that what are the things you have, m into n and p into q. Now one thing you must understand here is these two must be same. So if I take this one as I, this one as j, and this one as k, so I equal to 0 to m, j equal to 0 to n, and k, if I take this as k, 0 to q. Okay, this is how I'm going to take it. So let's go ahead and let's put that one. So I'm going to say for I is equal to 0, I less than m, and I'm going to press I plus plus, and after that I'm going to just put the second for loop, that is for j is equal to 0, j less than n. So I've taken this as a m cross n matrix here. If you notice, I've taken this m cross n and p cross q. M and p must be same, so I will just take this one, and I'm going to say j plus plus. Then I need one more for loop. Let me put the next for loop. I'm going to just put the next for loop for k is equal to 0 and k less than. So remember this, the idea here is you have m into n. So one is m into n you have, and then you have p into q is the next one. Remember these two are taken up. Either you can take n or p, it's up to you. I've taken it as n. The last one is left over is q. So remember that thing. Then you have k plus plus. Okay, done. What are the things that we are supposed to do it? So remember, before you add anything, I've already shown you there will be garbage value. So let's first clear the resultant matrix, this matrix that you have here. Let's clear those values. Whatever the old values are there, let's clear it and make them as 0. So I'm going to say c of ij, so if ij is equal to 0. So this is what I'm doing, is I'm just clearing the value. Otherwise there will be garbage values which are there. I've already shown you there. So what is that we were doing? So let's come back to it. Ij into ik, we are multiplying it and we are adding it. So we are multiplying it and we are adding it back. So let's add it back. So let's whatever value we are, let me go here, whatever value we are getting it. So new value of c of ij, the new value of c of ij is equal to the old value of c of ij, okay, plus the multiplication of these two values. Which are these two values? This into, let me put it there, this into this. So one into the other. So that's what we are going to do. So how do I do it? The matrix A, I comma, remember k. Why did I did that? I comma k is let me just write it, and then I'm going to explain to you what is that I have done. Remember, when I multiplied it last time, I've already told you. Now this row number and this column number is same. This row number I'm sorry, this column number and this sorry, other way around, this column number and this row number is same, this column number and this is same, this column number and this is same. In other words, if this is k, these two are k. What about this one that you are getting it here? This one and this one, they are I that I am taking it. What about these values 0, 0, 0? This is j. So you have two things. One is I, then this common one is k, and the last one is j. So this is what I am writing. If you look at here, so I common among them is this k and last one is j. This is what I'm writing. Once that is done, I'm going to just print the matrix. Now to make the things a bit beautiful to look like, I'm going to just put one printf statement before that, and I'm going to say product. Just put okay, product matrix. Okay, and I'm going to just put /n so that it looks beautiful. This is just a message that's going to appear here. Once we calculate one value, complete one value. So in other words, once we calculate this into this, so once we multiply, let me say, once you multiply this with this, this with this, and this with this, you just put the values over here. You just display the value. How do I display the value? I'm going to just use a printf statement here, and I'm going to say printf, and I'm because I'm using the integer here, and I will use /t for a tab separation, and then I'm going to print the value of c of I comma c of j. So this is what I'm doing. Remember, once you print one value, one row, once you print one full value of one row, you have to put /n so that it goes to the next. So you start printing 1, 2, 3, and then /n to go to the next. So this is what I'm going to do it. So after this, once one full row is printed, so let me go over here. Once one full row is printed, I'm going to just put printf, and I'm going to put /n so that it comes in the next line. So let me run and let's see how it's going to appear. So I'm going to just run this one. I think I have made one small mistake, and that is this is capital C. Okay, this is also capital C. Okay, then let me run it. So this is a bit case sensitive. Okay. So let me not. I think I should have pressed no here. Let me run it. There is one other mistake is there. Let me see what is it. One more place where I have missed this C. Let me put this one. Oh, I think here C. This one, I think when I typed C here, I typed it in capital. In any case, that's one small mistake there. Let me run it, and let me take the value as 3 cross 3, and the second matrix also 3 cross 3, and I'm going to type the value 1 comma 2 comma 3, and say 4 comma 5 comma 6, and 7 comma 8 comma 9. So first matrix. The second matrix, I'm going to take the identity matrix. You know very well this matrix, 0 1 0. This matrix, what I'm typing, this matrix is called as identity. What is the meaning of saying identity? Is like you are standing in front of a mirror. If you stand in front of a mirror, you must see your exact image. So that is what, maybe your left and right side change, physics people will say that, but when you stand in front of a mirror, that is going to show your identity. Same thing, when you take any matrix, if you put it in front of the identity matrix, you must get back the same matrix on the other side. How you get when you stand in front of a mirror, how you get your own image, same thing should happen with the identity matrix. So when I press enter over here, I must get back the same matrix. So if you notice over here, I will get the same matrix. If you get the same matrix, this multiplication is proper. Why it is proper? So remember, when you are typing, when you are calculating, what is that you are calculating? You are calculating this row with this column. Okay. Now, if you look at this rows and columns over here, There are two zeros are there. Zeros into anything, zero into anything is zero. What is left over is 1 into 1, that is 1. So you're going to get this one. You take, for that matter, you take this. How did you get this 5? 5 is you take this row, you multiply it with the middle row, middle column. So when you look at here, 4 into, if you look at this one, 4 into 0 is 0, 5 into 1 is 5, and 6 into 0 is 0. So what you get over here is 5 itself. So that's what is called as identity. So when you keep a mirror here, if you keep the mirror here, this matrix, whatever you have typed, the same matrix is going to reflect back. That is the property of the identity. So this is how we are able to achieve the product of the matrix. Thank you for your interest. We will meet again in the next video. Thank you.